Okay, so welcome to my talk, IT for Experimental Economics. And I thought programming would be easy. So what I show you is a little bit the perspective of an academic who's really interested in IT, who sees a really great use case here. And then I actually try to go with, well, not go alone, but almost go it alone and use the tools that I hear the guys talk about when I go to a meeting like this. And yeah, okay, well, you will see. So what I will talk about, I tell you a little bit about my background, why experimental economics, yeah, what is it, does it make sense, and why would you need a lot of IT for that. Then I show my 3 experimental economics apps. You saw this website there, so if you connect to that, you should actually be able to participate as a participant in the experiment. And then I finish with, do I still think programming is easy? Okay, so I'm an economist, yeah, I'm here in Prague at Search, but also in Ústí nad Labem at UJE. My background is economics, I have a PhD in that, I did psychology, then I did mathematics 1 year, and I actually have some IT background because I worked in a far, far away past for Capgemini and Ernst & Young IT when they still had an IT division. But I only worked there for a few months in 1996. Then I got actually a repetitive strain injury for 6 years, 2 of which very severe. That's actually a very, very bad story. But I totally got out of it, but that's a different story. I have some tips if you want to know, but yeah. It meant that I couldn't use a computer for 6 years, more or less. And then I switched to economics, something I wanted to do anyway. Yeah, but maybe I say this more to say, well, you know, I knew something about economics. Yeah, IT experience, so not about economics, about IT. I programmed a simple neural network in Pascal, and when I say simple, I mean simple. It was 1994. And then Capgemini and both Ernst & Young spent, or I don't know, maybe wasted some money on me, teaching me a 10-day Java, and after that a Lotus Notes training. So, I forgot everything of Java. So my time and energy goes to, yeah, so why do I say this? Well, yeah, because I'm going to show you some programs, and it's of course very scary when you are doing something and you are presenting it for people you see as professionals. So I tell you, my time and energy actually goes into a lot of things like teaching. I have to do some management, which I try not to do as much as possible. Then economic research and publishing. This is the most important actually. This drives my career, at least at the moment still. But then next to that I also do the building of IT applications. Okay, so I have these 3 apps. One about auctions, one about power plant investments, and the third one about exchange markets with forward markets. So these are 3 main experimental apps I made. The tools I used, so in the backend I use Django and Python, and then PostgreSQL as database. So when I came to these meetings for a long time, I didn't understand all this talk about, what was it, yeah, Node.js, I use Webpack, so I understand, I know it now, but what was it, state elements, structural elements? So yeah, Django renders everything, I have everything I need there, but then I need dynamic interaction, and then JavaScript and React is necessary.
jQuery?
There's some jQuery for it as well, because it's legacy, but yeah. So I did the backend, and for a long time I had an assistant. Yeah, but then he disappeared, so yeah, he ran away. So I also, yeah, I show these apps in this order, and this is the order we look at them, but this is actually the one I made first. There's a reason I show it last, because this one looks the best actually. Yeah, so what do? I actually made some experiments with them, and I even published with it. Yeah? So these are some of my publications. Now, why experiments? Maybe, what are we talking about here? Yeah, and we're talking here about theory-driven research. And I say, theory, not theory. But think of it, theory, that's just a very well structured idea. Yeah, and ideas is everything we run on, so if we like ideas, we also like theories. And in economics, academic economics, you have a lot of theories, and then you try to apply them, you start to look in the world, can we observe this really? And econometric papers, these are sort of papers that you see that are done a lot. These are what we call observational studies. There's an old idea, still from Plato, like, okay, we just observe the world and we know how it is. Now, for example, why have negative nominal interest rate had such a small effect on bank performance? Just some title that I took. So what do these guys do? They collect data, they analyze it, and they try to say something about it statistically. Observational data. Now, observational data has huge problems. And very often you cannot make causal claims from it. So it's not very reliable. Just as an example, to show one effect, let's look at this. Let's say I do this research, I observe this here, I observe 100 people, 50% of them dies, over a period, maybe say of 10 years. Okay, but what do I see? The ones who are smoking, 40% dies. The ones who are not smoking, 60% dies. I should start smoking, right? And then, we collect a few more data on these observations. And we find out that there are old and young people, and we should actually split them up. So, because then we find out that all the dying is mostly done by the old, while the surviving is done by the young, which is actually quite logical. And if we split it out, we see here smoking among the young. 25% die, not smoking, 0. Oh, okay, smoking looks to be very bad here. And for the old, 100% dies when they're smoking. When they're not smoking, at least 25% survives. So we see that this observation totally gave us a wrong picture. Now in this case, in this example, we solved it, right? Because there was a variable missing, we call this omitted variable bias. We found a variable and we correct for it. But who's to say maybe there are more variables behind this? There's actually no point that you can say we know this for sure. And this is just one of many problems. You can have reverse causality, insufficient observations, variation may not be enough for one of the variables, misspecifications in your models. So there are a lot of problems. Now, controlled experiments do not have this drawback. And this is also sometimes seen as the revolution in science, where the scientist said, no, it's not enough to just observe and say, now I know the truth. We are going to systematically vary some settings, and then we look what happens then. And this is what we call experimenting, and it's a controlled experiment. So how to do an experiment? Well, how do we do in economics, or how I do in economics an experiment? I create a sort of a mini market with real incentives and real payments. So I have these often students come to, but they could be any kind of people. They come to a room full of computers, they log in, and then they get a role. They could be a trader, or a seller and a buyer, and they are going to play this game of mine, and they earn points with it, or they earn money with it, and in the end of the experiment, we pay them in cash. Now, if you think about it, it's a game, right? It's an artificial economy, but an artificial economy is also an economy, and if our economic theories are to be true, they need to apply also on such an artificial economy. And so in this sense, this is a sort of a basic test that you can do. Artificial, but actually real. There are two of the founders of experimental economics, and we see that this guy actually really started with it in 1960, so it's actually a relatively recent science. Here's some experimental lab, so they have people coming, they sit behind here, and then they start to do their game or their experiment. I say that they are students, but why do we use students usually?
G.
very good, they're cheap, one. And second, they're also quite smart, which means that they are sensitive to the incentives that we present to them, yeah? Well, you can think that we built a sort of an environment, this mini market game, but it has, in the different treatments, incentives embedded in it. And sometimes you need maybe a bit more smart people to pick that up. So this is great, students learn fast, and indeed they are cheap, so if we offer them some money, they might be quite motivated to try to do well. Okay, so let's look at this first app. So selling to a group of bidders, highest bidder wins, and then you have different possible payment rules. So let's say I have some good, I have a painting here, I say, okay, I'm going to sell this. Who is going to bid the most? You're all going to bid, you write down the bid on a little piece of paper, say, or into this app, of course, and then I just select the highest one, the highest bidder wins, and then there are different payment rules possible. First price auction is FPA, winner pays its bid. It's usually what we think about. But you can also have that the winner pays the second highest bid. Like you don't pay your own bid, but you pay the bid that just lost from you. Or you could have all bidders pay. You have an auction, everybody who made a bid needs to pay. There are all kinds of ways that you can do. So what can you do in an experiment? Well, we can look at how these different mechanisms work. Is there maybe one that works better than the other? Now, of course, in such an experiment, we are not going to auction a painting, right? So we are just saying, okay, we are going to, well, we're not really selling something, but the person who wins, he actually earns some money. And this is usually, this can be different for different people, but in this game it will be the same for everybody. So there's some number for this, and no, like everybody has its own value for the good. And we just say, okay, if you get the good, sorry, I get confused myself. So we sell a good, you win the good, then the value we express in money, and this goes to your account, and in the end of the experiment we pay it to you. And so we run this game, but this is actually not what I did really. I wanted to keep it a bit more simple here. We were actually interested in what happens when the bidder doesn't pay. He wins, the winner wins, but he doesn't pay. This is possible if it's about contracts, for reverse auctions, procurement auctions. And then there is something like with EU governments, auctions, subsidies for wind farm subsidy systems. But we see many of the winners default, and we're thinking of a smart penalty system. This is the full idea, but we just look at the more simple version. Okay, so let's say this is what I want, and now I need to create an auction app. And I want it to be interactive. It should record all responses. I should be able to choose different treatments. And the first app that I made, the experiment was super difficult. I was thinking, I wonder if these students are going to understand it. And if they don't understand it, they're going to make random responses. And then, then nothing comes out of it, and then I cannot publish it. This is how it works. So I thought it needs to be very visual and very clear. So even though it's difficult, they will understand it. Okay, so what is the state of the art of these apps? Okay, so, all right, well, honestly, this is from 1978, but there's like a pencil and paper. So this actually worked for him. But okay, this is terrible. They have to calculate it all themselves. Okay, this is a little bit newer. This is maybe 2021. Okay, but these are the games, and if I see this, I already fall asleep myself. I'm like, I'm not going to play this game. Screw you. I'm just not going to do it. This looks really boring, and I don't understand what it's about. Or this. That's already slightly better, but it's still terrible. This. Well, it's graphic, right? Nice. Okay, at this point, I had no assistant for front-end anymore. This was terrible, so I was like, I have to make it, and my assistant had disappeared. I think he was Czech, he now lives in America. So I have to take this book and start to read it, and then I have to start to visit this organization so I can hear some things around me, you know, what's going on. And this is, I don't know, this is 1.5 years ago, or maybe 2 years ago or something. Yeah. Okay, so now if you go to this page, you probably see, if everything goes right, you will see the game running. And you should be seeing this here. I can have a look here. Okay, I see several people are already logged in here. Yeah.
The QR code is covered.
So what?
Yeah. The QR code was covered when you opened it up.
That's not good. Okay, so what do we have here? Yeah? So this is like this is the bidding, and you see here on the horizontal line you have the value. So I'm playing here, right? And I see my value is 20 for the good. So if I win this round, I get 20 into my account. But if I win, I also pay, of course. And this is a first prize auction, right? Because you see here, the winning bidder pays its own bid. Yeah, so it's not so great for me to bid exactly 20, right? I would like to bid a little bit lower. So I can actually do that by moving the bid here. Yeah? I can also move these things, these red ones. Now, what you see, and I think as an economist, this is very nice. Yeah? I mean, if you play this round to round, yeah, your value is going to, well, let's just play around. Yeah? So I just let, because it's now, so and now we're starting, yeah, now we're bidding, so I see there are about, I think, 10 people or something. And let's see. Okay, so I did not win. I probably, I'm not sure if I can see here who won. Actually, I cannot. Anybody here won? No? Yeah, okay. Congratulations. Of course, I can make sure to win by just bidding ridiculously high. Okay, so now we have some time to review, yeah, because we have to understand what's going on here. And now we get to the next round. And you see now my value before was 20. And now it is 77, and I'm bidding 136. That actually doesn't make a lot of sense, yeah. But I really want to win. I'm even willing to pay for it. And I did not win. Somebody bid even higher. Okay. That's crazy.
Maybe someone can see how we are bidding.
Yeah. That would have been fun to show, but actually that's somewhere in the database, and I don't know how to tease it out just like that. Now, why is this? Why do I think that this is nice? Yeah, now I won. Yeah, okay. So nobody was crazy enough to bid 150. Yeah, because the values are between 0 and 100. Yeah, so okay, and I have a negative amount. Yeah, so that is possible. Now you see that between the rounds, my values are different. Yeah. And if you look at economic theory, we expect, or it actually makes no sense not to have an increasing bidding function. Yeah, if you bid say 40, if you bid say 10 for 20, let me put that here, then I would not pay 5 for 40. Yeah, that doesn't make sense, that it goes down. So this is nice because this enforces that. Yeah? Well, actually, you may actually violate it, yeah, because you can actually still move this thing, but it does remind you, this whole thing here, that it's actually not so logic. And I've seen experiments, so an auction experiment, I think this is really useful, because I've seen auction experiments, and they find actually that people do not conform to theory. Yeah, because for a bidding like this, we can calculate as economists what is the equilibrium, Nash equilibrium bit as we call it. But we see that people are actually very bad at that. But one reason could be is that they get these different values and there's a lot of error going on, they did a bit too much, a bit too little. But here they have everything on one screen actually. Yeah? Of course, here they have all the numbers, which is what you usually see in an experiment. But that doesn't give me so much information. But here, look, what I see here, I can see very clearly kind of, well, I'm bidding, sort of my bidding function is starting to form itself. And I can also see here these rounds, like this bid, okay, I bid there 43 and I lost. Okay, but here I won, yeah, here I won, and here I won. Okay, so this is something you can do in JavaScript React, right? And I think this is wonderful. I also really like that I can, as input, just be dragging curves. I think that's really nice. Okay, so that's the app. That's the auction app that I made. Okay, what I think is nice, so I use chart.js, and I only use it actually because I could use drag data, some plugin on it, that I can move these things, and then it has a nice way to handle everything, the information, the coordinates that then are sent to the app. Red line is the bidding function. It takes away some complexity from subjects, so more chance that the subjects do something that makes sense, that gives me the sort of statistically significant outcomes that I like and that I probably can publish. Prevents inconsistent choices. I use, so for the first time here I used WebSockets. Before I used for these games Ajax calls, and then you have like these hundreds of Ajax calls all the time going on every 2 seconds, and it's terrible. Yeah? WebSockets, I don't know, maybe there's also a drawback to them, but I didn't find it yet. I think they're really wonderful. It works on the backend. Django has something called Django channel, so you can catch that. What I like to, because before I made a mistake and I had calculations, I delegated it to the database. I just pushed to the database and said, okay, you just order everything and find the right ordering here. And this was a very expensive database hit. Well, very expensive. I think 8 milliseconds or something, but then you have 20 people playing and then you cannot have more of them. So here I do the calculations in memory and save them to the database every 6 seconds. So if some idiot refreshes his screen while bidding, he might lose maybe the last few seconds, but that's his own loss. But everything before that is then just taken out of the database and refreshed. I regret not understanding hooks better. So I find React really mystifying, but it seems I understand it enough to make this app working. And it's embedded in very old back-end code. So I took a long time writing this app, and the whole thing it's embedded in is really old, and it was written by me when I understood very little of Python and Django. Okay, and then I have a power plant app. This is a very cool app, I think. This is a little bit simpler. It looks like this. So let me just switch to that. I think that you should also see. So what's going on here? Well, because I'm also an energy economist, so I try to teach people about how should we expect, what is the optimal way to invest in power plants. We have some theory for this, especially. Let's see. I think okay, it's working. Okay, good. Yeah, so it's not the place here to talk about theory, I guess, but so you usually have something that over a day you have a certain demand. So this is the demand. We have the highest demand for electricity in the middle of the day, and the least one in the night. And then you have to think about, okay, how much nuclear, coal, gas, and oil am I going to build? And Here these numbers are not so clear, but there is a thing with fixed cost and variable cost. So the fixed cost I have to pay for every unit that I'm going to put into, but then when this round ends, we're going to run a typical day. Well, actually, we draw a day. This day is mostly like this, but maybe slightly different because of random variations. And then, depending on that, you dispatch the cheapest plans. When they are running, this is the variable cost. I can tell you, okay, the idea is you need to, you see that the demand till 1, there's always a demand of 1. There's never a demand less than 1. Yeah? Well, at least typically. So with the random, there could actually be 0.9. So something that has huge fixed cost but low variable cost like nuclear, you build up till 1 or maybe till 0.8, because then your short can run 100% of the time. Yeah, but you cannot leave it at that, because then during this time there will be a blackout. So then you have to put some coal, gas and oil oil has very low fixed cost but very high variable cost. Okay, so let me just let's speed it up a bit. I cut the timer here, and we're at the end of the round. Well, it freezes, that's a good sign, you know, because that means that he's calculating the backend, I think. Yeah, okay, it actually works. Very good. Yeah. So what do we see here? Okay. Yeah, so now we are actually for a new round, yeah, because I would like people to learn and they can adjust their choice. But here we see actually the outcomes of what we just chose before. So what happens? Yeah, we see that the nuclear is dispatched all over here. Then on top of it, we have some coal here, we have gas, and we have oil, and actually we have a shortage. But actually, the whole reason of this, well, one of the lessons of this app, you should have little shortage. You want sometimes the price to spike because that's the only way for the oil generators, the ones with the highest variable cost, to recover their cost. And then you can look here at the price. You see, okay, so the price here jumped up here. You can look at. Okay, so ready to the next round. Okay, yeah, it goes a bit faster. Okay, fine. Here we see then the demand prediction. So this is the demand prediction, but we see that demand was actually higher in this round here. High scores this round. Okay, you see Alex has a high score of -100. I have a score of 1762, but I don't see it. So something is not totally right. Yeah. Okay. So I don't know why that is, but I actually added this here because I use it for teaching, and then it's fun to see the high scores. I don't know why it doesn't get that. And maybe because some of you are on your mobile phone. I don't know the Wi-Fi. Anyway, so this is I think this is a cool app. You can then also at some point add CO2 prices. And so I have a whole lecture of, I don't know, of 2-3 hours where I talk about economic theory, then I talk about energy, and then I use this app to play with them, and then they understand a lot better, usually. I have been thinking of doing an experiment with it, but I don't know really how, because to understand this app, it takes, I give people a 3-hour session and then they understand the app, so how can I do an experiment with it? The experiment should be easy enough that you get a group of people in, they start playing, and then after 2 hours they're done. Okay, so that's the... what I think is nice, it's colorful, it's very important, great tool to understand energy econ topics. You can understand better maybe energy diagrams, because then you very often have this is the amount of electricity produced by nuclear, and you have this bar here, and coal and oil. And here this comes quite naturally, and they are stacked according to the variable cost. The ones with the lowest variable cost comes first, and then the later after. You can explain peak load pricing with it, which is a complicated topic, but here it already it works. Well, it works mostly, right? So we didn't see the high scores for some reason. I regret. What do I regret? Old. Yeah. Well, so my assistant wrote the React part, and he used old JavaScript and React. But am I going to upgrade it now? Yeah, actually, I think the app works as good as it must. And, in a perfect world, I would spend time on it if I didn't grow old and die eventually. But probably not now. Okay, then we come to the last app. And this was a beast. This was so hard to make. This is actually when I started and I thought programming will be easy. And then I realized how much came to it. But let me see. How am I with the time? Okay, I should slowly close now. Till what time?
Yeah, I have no watch, unfortunately.
It's 1924.
Yeah. So if you can speed it up, then.
Yeah, okay. So then I don't run this app, and that's good because who knows, maybe it could crash, you know. This was otherwise this is a cool app. This is a trading app, so it's like an exchange market, and then you have like buyers of stock, buyers and sellers of stock, and people have to make, they have to put here their orders into it, how much do you want to sell, how much you want to buy, and then they are all written here, and if an exchange is made, then you see here in black actually the price for which it went. And here we still see all the open asks and sells in red and blue. And this is very nice, I think, because in an exchange market you will usually just see these numbers here. But this is, I've never seen this actually, and this is actually very clear to students as well. I also talked about supply and demand before, and if you look at it, this side here could be the right-hand side of a supply and demand curve, if you know what it is. So this really nicely connects to theory. What I think is nice, again, colorful, great tool to understand foundational economic topics, exchange market, double auction, supply and demand interaction. We actually did it with forward markets. It works, or it mostly works. I regret. Old JS React. I regret it a little bit, but not that much. Input could be better, easier, faster. It's a bit slow here putting it in, and this is a sort of stressful game. So I think that, I tried to play with a lot of people, and then it didn't have enough performance, so could do something with it. Okay, so we're almost at the end of my talk. So I talked about my background, why experiments, my 3 experiment economics app. And do I still think programming is easy? The hard stuff, the programming, Python, Django, Pandas. Pandas has a total different logic than Python. JS, React, oh my god, yeah. So really hard, unexpected things that baffled me. Using understanding, I have to use an editor, PyCharm. Git, what? How does it work? I don't understand. Git reset or hard reforce update. Deployment, going from dev server and then having to install and configure Unicorn engines, cloud Linux servers, Linux, going synchronic, virtualizing. First use Vagrant, after that Podman. Alter new JS and hooks and keywords of this that I never understood. Integrating JS, React, and Django. Okay, Webpack. But actually, I guess it's okay once you've handled it. You've done the configuration, and then you just try not to touch it anymore, and then it keeps working. So that's okay. But the first time, as an outsider, you're like, what? Do I have to do this? Didn't they solve this in some better way? ChatGPT helps. Still hard. What I still find really hard is organizing and maintaining code. To write that you don't change something here and then it breaks there. But from my visits to the meetings, I got the feeling that I'm not alone in this. Would I advise this to any of my students? No. It can kill your economist career, I think. It was much more than I thought. The thing is that at some point, there's something we call in economics a sunk cost fallacy. If you sunk cost in something and it's a bad project, should you continue? Well, the answer is no, but then people tend to do this. Now, as an economist, I of course don't fall for this. But I was like, okay, it wasn't as easy as I thought at all. But now I learned a lot, so now it's going to be easy. So I'm still waiting for the moment it's going to be. Okay, so let me just evaluate, yeah, as a last point. What are the successes? It's actually unique, high quality graphic educational software. Students and colleague profs really like it. My regrets, it's fully dependent on my efforts actually. Yeah, and that's of course a problem because I have all these other things to do. And one reason is that the project is messy and undocumented. So who can maintain it except me? I try to improve it, but you know, that takes a lot of time. Not used by anybody but me, yeah, because I had a prof saying, can I use it? I said, yes, you know, just download it from GitHub and deploy it on some server. I mean, yeah, no way he could do that. So I should make some web page somehow that where people can log in and then use it. But I don't have time and funds to do that. Okay, yeah, so that's what I like about programming is it can, okay, yeah, I'm not going to talk about that. I just finish it.
Okay. Actually now, I understand that you're coming for almost 2 years or so to prepare another experiment on us, right? Like to understand how programs think or something like that.
Yeah. No, but also because I was like, I have to finish this because I'm writing a paper and this paper has to be published and I have to make it and nobody's going to make this app for me and I have to make it and then I couldn't talk to anybody around me because economists are all with other stuff. And then I thought, you know, at least I go here, I get a free beer, you know. Also, I can just run away from my computer in my most terrible kind of clothes. Nobody cares. So yeah, it was kind of. I also live very nearby actually. So it was great, and I really enjoyed it. And to my surprise, I actually understood what they were talking about. So it was very rewarding. Yeah.
Seriously, it's quite interesting to see someone from completely different background actually doing some programming and how you see it. And it's interesting. Any questions to Silvester?
It's not questions, but I have experience with academic software in early 90s, and from my experience, you did great work. Because the program we used in the 90s was, I remember it until the young days, it was, you will start command line command with MH, BB, and TB, and there was some software evolution biology, and so on. And your academic software, even you are, I think, not amateur, but you start like amateur, it's nice for users. Users were always in your side, so it's great.
Oh, thank you. Yeah, this is true because you see actually that this is my backend view. Yeah, this is terrible, but it's for me, so I didn't care much. Yeah, as long as it looked good for the user. Yeah.
How do you usually present your apps in the papers? Because I imagine you said that you wrote the app, built the app for the paper, and then I guess you have to talk about the app in the paper, yes? So do you just like, I guess you have to document it with screenshots and do something like this?
Yeah, exactly, something like that. And then of course I say, oh, it's here on GitHub. Yeah, so I put a public version on GitHub. Anybody can download it and check it. And
has someone actually checked it? Like,
no, definitely not. they would have called me to ask like how to do it.
Yeah, another question, just a side question. What's the Linux desktop environment do you use? Nice and minimal.
I use Linux Mint. I use on my laptop, but for server I use Alma Linux now. And I actually started using Linux to force myself to understand the servers because suddenly I had to use Linux servers.
Did that help?
Yeah, it helped a lot. Yeah. And I started to love it, and now I can't go back to Windows and I look down on people with. I shouldn't say that here. Yeah.
Wasn't there an option
Max?
to ask some of your students to help you out
by doing their thesis on this or something like that? You could have somebody to help you out.
Yeah, not really now, because I just needed programming done, and I've tried to employ a number of students, yeah. So this one assistant that ran away and that wrote all the old React, he was actually the best of them all. He was actually exceptional, and then I had other people work for me, and they were totally unproductive. There's nothing, they could do very bad stuff that I can do 10 times better. Yeah, it's sad, but what we did in the beginning is we hired a guy to help us. Yeah, so he actually set up the Vagrant and had some tips, and then later I paid the guy and we had some sessions with him, and he explained this like, I know you have your engines and you have Goodicorn, and you communicate with each other, and you have to set up both of them, that sort of stuff, or about Django more specifically.
Jim, what's your favorite YouTube channel about economics?
About economics. That's not a good economics YouTube channel. Sorry.
Do you plan to run any following experiments probably related to the different?
Yeah, definitely. Yeah. This one is not this. Let me see. The one we started with is something that we're working on. Let me have a look. Was there? Here we go. Yeah, this one. But there is different. Because there will be a first round here where you have to decide whether you want to enter the auction, yes or no. And then only when you enter, then you come here, but then you're on an auction and there can be nobody in the auction, only you, or there can be 2 people, or 3 or 4. So I actually then have several of these lines. It's actually much more complicated. But this is interesting because we see that in these renewable auctions, the problem is that people may actually not enter the auction. People are not in what's being offered is not so interesting. Yeah, for these renewable wind, there's subsidy, but there's a level on the subsidy. So people may say, oh, it's not so interesting, and not so many people enter.
How do you ensure that these experiments are really reliable? Like, there was a lot of controversy around, I think, Dan Ariely and his experiments.
Oh my God, yeah.
To this.
Well, Dan Ariely is a fraud, right? So, I mean, and Nino, there's this lady, Nino Gigliotti or something like that. There's some lady who wrote a paper with him too. They actually this lady liked to write papers about lying and cheating.
Yeah.
And she showed in one of her papers that cheaters are more creative. And then it turned out that all her papers were cheated. It's incredible. We don't make this stuff up. So I don't know, how do you...
But I think even his earlier experiments were criticized that, these are just games and the setup is not as reliable as...
like fundamental like cherry picking data or something like
Yeah,
that?
this is the fraud.
Okay, so we talk on the one hand on fraud. So I'm not planning to do fraud, yeah. But, I might do it, but then they might find out, and then my career is destroyed. I don't know.
Yeah.
Maybe I could find another job in another branch, but that would be terrible. But
in the room there were like 18 computers. Is it like enough?
yeah. So we would do this experiment. We might do it with a group of 4 people or 5. Yeah. And if you have this supply and demand, we find that if you have 4 people, 4 buyers and 4 sellers, you have already a very competitive market. Yeah? Surprisingly, you wouldn't expect that. Yeah? Theory talks about an infinite number of buyers and sellers, and then we have a competitive market. But we find out you only need 4 on each side, maybe even only 3 on each side.
Okay.
I mean, of course, the price will jump a bit around, not always be precise, but it's quite close.
Okay.
Great. I think that's it. Thank you very much.